Is that time? 6:20? Come on, that was my best goal. Very good. Welcome to our. I see we have more industry influence here than I was expecting. This is nice. Hey, welcome to the joint Docker and CNCF meetup. I'm tickled that we finally figured out that we should have one of these and schedule it last Thursday. Moreover, I'm tickled you guys found out about it and came. First time that we're hosting this one in the Calcote factory. For how many of you guys here, just out of curiosity? Well, so how many are local? Bradley, some familiar faces. That's pretty good. How many of you guys are? How many of you are attending KubeCon?
Yeah.
Very good. That's a silly question. Good. Well, we've got a couple of talks for you today. We've got a featured coming straight from Docker, from Justin and Cormack. We've got a couple of lightning talks that you're going to have to put up with just to get to the featured talk. This is our agenda. Yes. It's rather straightforward. You know what's interesting about tonight's meetup is that for the ones that we have locally, where there's not necessarily affiliated with the conference, there's a lot of familiar faces that we generally see, right? I have to say, actually, I think there's more familiar faces with the conference in town than there is otherwise. This is kind of funny. I'm really happy to see folks like you there in Patrick. There's a bunch. Mike. Yes. Mr. Aaron. Yes, all right. Now, if you're thinner in person, by the way, that's not true. It doesn't yeah. All right, well, hey, this is a better looking version of me. And hopefully we're recording. Speaking of folks, there's Mr. Joseph Jacks standing outside the door. Hey, thank you to our sponsors. The beer was actually, no, the beer and the venue and all, thanks to Docker, thanks to the CNCF. They sponsored this evening. If you didn't necessarily take note, at last DockerCon EU, those worlds are continuing to just come closer together, both in spirit and in software integration. We typically kind of kick things off, do a little bit of announcements in and around the room. Austin has had the fortune of having a number of technology conferences come through, and so a couple of them come back this year, and they're kind of doing their rotation, and we expect some won't and some will. But for those of you not attending DockerCon and looking for something else to do this week, there's a very academic, research-oriented UCC conference happening. I think in the Marriott. They reached out some time ago trying to find their way, and apparently I'm the biggest geek in town. I actually don't hold that title, but we were actually talking with them about some things that we do in my day job, which is at SolarWinds, and the people putting on that we got connected with. So anyway, another one that's happening. Anybody going to Czech Republic next week? All right, very good. Well, this is for. Well, that's weird. Hey, we're hosting. Okay, this actually doesn't matter. We're proud of our one-day event, so we're gonna do more talks like this. For those that are local, actually, for those that are even remote, this is an opportunity to kind of talk about it. If you're looking for a role, or if you're hiring, feel free to speak up. It's a good way to connect with talent. And yes, sir.
I would just say check the Google Jobs page. We're hiring a lot in the cloud side of our vertical for customer engineers and sales folks. So we're being asked to let people know that there's tons of availability.
I noticed you've got an awesome so locally.
Local, yeah. Seems like there's a lot of great, smart local people here as well.
I'm from San Francisco. We'll ship you out there too.
Chicago? Nice. Anybody looking? It's nice. Time to Google.
Well, yeah, I'm looking.
Wait, Google Chicago. I mean,
There is an office in Chicago.
I've been there.
Oh, awesome, yeah.
30 minutes away.
If anyone needs a reference to say you're here in the biz.
I'm a software engineer. I'm looking for a DevOps infrastructure SRE role. Just starting out, but want to, yeah.
Here in town? Or
No, here in town. Like I'm based on the Dominican Republic, but I'm looking. I can move. I can relocate. I can work remote.
Snatch them up quick.
Same here. My name's Troy Powell. I did a lot of work with the Anaconda, the Python big data scene, looking for DevOps and like infrastructure type of work, and particularly startups. I've been part of two startups, helping them grow from the ground up, and I was looking for more opportunities to help out new companies.
Excellent. Formerly of Continuum? Mm-hmm. Or, okay, I guess. Very good. Hey, anybody else have anything they want to share in general? Something they learned that was something that blew their mind? Or?
Hi, I'm Paris. I work at Google. I actually work on upstream Kubernetes contributor programs. If there's anybody here that would like to contribute upstream, which you should, everybody in this room should, reach out to me on Slack. It's Paris, P-A-R-I-S.
Anything else? Everybody? All right, well, all right, is there a particular topic people are looking forward to this week? Those other things? All of them? All right, well, with that, I want to invite up Justin Cormack of Docker. Justin's going to talk to us today about how to build Kubernetes with LinuxKit. That's actually working despite the fact that I didn't press the key to the right of the shift key, which was slightly hard to find. Okay, so I'm going to talk about building Kubernetes LinuxKit, which is a project that I've been working on, and Ilya from Weave here has also been working on for about 6 or 7 months now. So it's kind of getting kind of mature. I work in the Cambridge UK office of Docker, mainly on open source projects, but and I also worked on Docker for Mac, which I'll talk about a bit later as well. I'm just a Cormack on most things GitHub. Cambridge UK is a funny place. It's a sort of science village. This picture is just up from where I live. It's
That's a lot of TPM console at one point.
Sorry?
That's a lot of TPM console at one point.
Yes. 50 years ago here, that was where Jocelyn Bell discovered the quasar. But anyway, it's sort of, this kind of reminds me, I mean, this is Cambridge really. It's just a very small town that does a lot of tech and science. And it's a kind of interesting place. So first of all, I'm just going to talk about why LinuxKit, what it is, why you might be interested, what it's for, why we're trying to do it. The project actually started in 2015, right at the beginning of when we were working on Docker Mac. We needed to embed a kind of Linux into it to run Docker.
and it was really kind of, it just needed to be simple, embedded, and but customizable to do the new things we wanted to do with Docker for Mac when we were switching away from Docker Toolbox. And it kind of, over time, it became kind of more and more useful for doing other things other than Docker for Mac, and we really kind of shifted it towards that about a year ago, and then we open sourced it 6 months ago, 7 months ago now, as a kind of project that other people should be able to use for totally different things that are nothing like Docker for Mac, like maybe running Kubernetes or something, or many other things. So you want to run Linux. LinuxKit lives up to its name. It's a kit, it really is a kit. It gives you a lot of pieces that you can use for running Linux. And like any other kind of kit, everything can be replaced. If you don't like the bits, we give you enough bits to kind of get started. Feel free to throw them away and use other bits if you prefer them, or they're more useful for your use case. It's really designed to be built and tested in a CI pipeline. It's a kind of modern cloud native kind of Linux. It's not designed to be, there's no sort of manual install process or any of that stuff. I'll show you later, but it really is, config file, build, test, test, deploy, go into production. So it kind of feels much more like a kind of mode of using software that you're used to using containers. It builds in about a minute or so, which means it's really quick, which is useful. There's no twiddling your thumbs. A minute, now does feel really slow. I mean, when Linux distros took, an hour or so to build and install, whatever, you kind of, when it went out a cup of coffee, but it takes a minute, it's really annoying, so we're probably trying to make it a bit faster. It boots fast, you can test it locally, and then ship it to production, and it's small and just designed to do whatever it is that your application requires. And it's designed to be immutable as well, which makes it much simpler. I think immutability in software is something, again, that we're used to from containers. You don't log into your container and update the code in it, you deploy a new one, it's the same thing. Why isn't all your infrastructure like that? Immutability for infrastructure is something that has caught on more slowly than immutability for application deployment, but it has exactly the same advantages. That you can test it better, you know exactly what you've shipped, and there were quite a lot of, this was from a paper by Netflix back in 2011 when they started doing that, and it's something that really does make sense in terms of infrastructure once you think about it. You build a machine image, test it as is, ship it, and then when you want to change it, you ship a new one in. Minimal Linux systems are really good for running containers. This is from the NIST security guidelines, which suggests that you should always use a minimal operating system for running your containers. That's the kind of recommendation when you look at it, because running a gigantic Linux distro that's designed for doing all sorts of other things is just really complicated and liable to have security holes just because of the sheer complexity. There are other minimal Linux distros as well. I think when we look at it, I think some of the differences between those and LinuxKit should become clear, but I think you'll answer questions about that as well. So I'll just give you a little kind of impression of how it actually works. LinuxKit uses exactly the same kind of model as Kubernetes pods. So if you know a bit about Kubernetes, it's kind of easy to understand what goes on. There's an initial sequential startup phase when you run a bunch of containers to completion one by one, and then you run a bunch of services. So the on-boot ones, they basically set up the state of the machine in terms of, with the system containers, they do things like configure your networking, configure any kind of persistent disks you have, make sure everything's formatted and whatever, mounted and so on, and then you run the services you're actually interested in. And those services might be Kubernetes, or they might be Docker, or they might be, you might just run your application directly without any other kind of container management system, depending. I'll talk about more in a minute. And everything's configured from a YAML file. It's relatively straightforward. You have a kernel. The initial stuff that sets things up, container database, whatever it. On boot, this one runs with DHCP to configure its IP address, and then it's running Redis, this example here, and then getting the login. But basically, it's built example that runs Redis. And it uses a standard off-the-shelf Docker Hub standard Redis container. You can pretty much use containers unmodified as system containers for running your applications, which is really quite useful. I'll give you some more examples in a minute when I do some demos. There are kind of differences to other distros. So there's no package manager. You can't do anything at runtime, so it's immutable. And the root file system's read only. You can't really change anything. So it's really it really forces the whole immutability thing. In terms of practicalities, there's a bunch of tooling which will do things that you need to do with system images. Build ISOs, build AMIs, build PhDs, all the kinds of practical things you need when you're actually boosting physical machines, which are annoying. There's kind of straightforward support for most of the cloud providers and kind of bare metal machines and whatever you need. Adding more tooling like that's quite straightforward because it's just a bunch of containers that does format conversion. And there's a simple kind of build and push workflow for different providers. As I said, the cloud providers and then a lot of local desktop environments so that you can do local testing on VMware desktop or HyperKit on the Mac or whatever. And the workflow is pretty much like a kind of container workflow: build, push, run. So it's kind of has that sort of feel. And there's a few platform-specific options for doing things, but really it is pretty much that simple. Straightforward things. As it's CNCF gone, these are kind of it's very much a cloud-native project and uses a load of CNCF projects. We use Containerd as the runtime, which uses gRPC, has Prometheus endpoint, gives you machine status, Kubernetes and CNI if you want to run Kubernetes on it, and Notary and Tough we use for image signing. So that's for signing the system images that we build. So it's kind of very much kind of integrates in with other CNCF projects. Containerd is really important for LinuxKit because it's what actually runs services. Containerd is a really lightweight container runtime that we started building just over a year ago in conjunction with, we sat down with the Kubernetes maintainers, particularly at Google and other people who are in interest, and basically sat down and said, look, what do you really want in a container runtime for Kubernetes? Because everyone been complaining that Docker does too much stuff. We'd added swarm mode to Docker. It was really much more than a container runtime. It's a whole platform, and Kubernetes just needs a container runtime. So Containerd was basically what we built from that feedback about what people wanted. It's just the minimal thing that can pull containers, run them, and integrate easily with other systems, particularly Kubernetes, but it's also, it's obviously been shipped as part of Docker as well, and it's got a whole lot of other use cases. And it's a really useful runtime for LinuxKit because it can sit there and it can run both the system containers, and if you're running Docker or Kubernetes, it can also run the application containers as well on the same runtime. It supports namespacing so they don't get confused. And there's it's about to have a 1.0 release, possibly as soon as tomorrow, I hear. After which we'll start doing the first LinuxKit official releases. We've kind of been waiting for that. So Kubernetes, I've mentioned Kubernetes a few times. Just before we open sourced Kubernetes, we talked to a bunch of people, including Elliot here at Weave, and said, look, we're about to launch this thing, and one of the things we'd like to do is explain to people how it's useful for doing stuff that's completely different from what we've been doing. And one of the obvious things to do would be, why don't we run Kubernetes on LinuxKit? And so we actually Solomon demoed it at DockerCon in Austin earlier this year, kind of running Kubernetes on stage, which was kind of precursor to our big announcements about integration with Kubernetes and Docker. We're a bit sad that no one knew that except us at the time. Maybe help them guess. We've carried on that work since, and we have a lot of people who've been really interested in running Kubernetes on LinuxKit. It's now all in its own repo at GitHub, LinuxKit Kubernetes. So it's it's designed to be absolutely standard off-the-shelf Kubernetes, run with kubeadmin. It's designed to be as customizable as you want. You can choose your networking plugins and so on. You can add in extra customizations as much as you like. It's really designed to be off the shelf, and we're going to try and make it much more usable. I'll demo it in a second, but it's designed to be. We use it for as the upstream for the Docker desktop editions with Kubernetes support, which I'll show you in a second. But it's designed to also be used as in a standalone way. It's not as usable yet as we'd like, and we're working on that. You got a question?
Yeah. So you're containerizing the kubelet with a system container, and so my question is basically around. There's been many efforts to try to containerize the kubelet. Most of the painstaking feels around the kubelet ultimate wanting to manage C groups. How are you getting around that? There's still more. We still need to do a bit more work. It does still own the whole machine, which makes it easier. I think I've been having some discussions with people who are trying to containerize kubelet because they want to run multiple kubelets, which I think is much harder in the current status. But at the moment, it still gets to own the whole machine. I think there's definitely still some work to do on that. I just kind of started doing a bit just kind of last week, and I think we definitely want to contribute in this because it's there's definitely some issues, and it's kind of not all there yet. But I think it's kind of more or less okay if you're not trying to do multiple ones, but it's because at least it still owns everything, and we've got control over secret placement for all the services and things, mostly, except we need to look at containerd itself and how to configure that a bit better. So yeah, there's still some work on that to do, but it's if anyone wants to help, but yeah, it's definitely one of the things that's right at the top of my list right now. Thanks.
And in the past, one of the problems was that there are different versions of Docker that users may have, and they may end up running in a different version of Docker, and there could be some edge cases where one version isn't compatible with what Kubernetes uses. So in this system, it's kind of like it's coupled in a completely different way. And now we're not even talking about Docker even in use containers.
So Docker for Mac and Windows. So very shortly we're going to launch the beta for Docker for Mac and Windows with Kubernetes support. It's going to look like this. There's going to be an extra tab saying Kubernetes. You tick it, enable Kubernetes, and Kubernetes appears and it works. That's kind of how simple it's going to be. In fact, is now because it just does work like that. There's one other. But then everything should just work. KubeCode's already installed. You can just run stuff and it's there.
hoping the beta program's going to be launched this week. Fingers crossed. Otherwise, very shortly. I think you can sign up at beta.docker.com, and then we'll. I think we're. But yeah, it's we've been testing it internally, but it's going to ship any day now as a kind of test on top of the normal Docker Mac. Ship with Docker Mac first, and then Docker Windows afterwards. But so if you sign up on the beta program, basically you will get the little enable Kubernetes button, so we can. But please, everyone who uses Kubernetes, please do sign up, because we'd love feedback, because I'm sure there's going to be a few issues before we open it up to everyone. But basically it's going to be, just exactly the same. I mean, it would be really straightforward. I'll show you a bit more of it in a second as well. Let's stop presenting and do some stuff there. So yeah, I've got Docker Mac installed here, and as you can see, it's got Kube 1.8.2 currently, and you can see the preferences dialog here. And to turn that off, it would just restart. I think we're actually going to have it dynamically turn off and on and off shortly as well. So that's and then basically it's really, you've just got you've got Meetup installed. It's there, and it says it will tell you it's top of the Mac, and it's running LinuxKit, and very straightforward. So that's just it's got everyone we have millions of people run Docker Mac and Windows, and they're literally all going to just get Kubernetes just as simply as that, which I think is really exciting. And so that's all built using LinuxKit from the same upstream open source repo as LinuxKit / Kubernetes.
Would it also support clustering? If you want to add more, just use.
Yeah, so we've never actually supported clustering on the desktop product mainly because the UIs for clustering is a bit annoying, and I think it's actually someone actually implemented it a while ago, and it's never been enabled because it's kind of confusing. There's not that many people who want to use it, so it probably won't be enabled. But we want to make the upstream version so easy to use that if you want to kind of use cases like that, you can just use that to do that, because that's because basically clustering does work, and you can actually connect to it, but it's by doing the join by hand and things like that. But it's kind of it's a bit fiddly. So to do it by hand is easier, but you can actually just build the cluster yourself. It does actually work.
Justin, is it a single node cluster?
This is, yeah.
Like a tainted master?
Yeah.
The Cube ADM was?
Yeah. It's untainted, yeah.
Cool. Can you confirm that it's going to land on Docker for Linux in both the enterprise and the community edition? And are there any updates on that?
The implementation for the different things is quite different. So the Kubernetes board in Docker EE is basically piggybacks off some EE code, which basically already was running an etcd cluster, which was originally there for running Docker Classic Swarm mode, which had an etcd cluster. So that code is all part of the EE install. At the moment, we're not prioritizing integrating a Kubernetes installer into CE, because I think generally I think everyone who wants to use CE can just install Kubernetes. It's not clear that there's a really strong value add for us to produce some sort of installer around that, because there's loads of ways of installing it already. But things like the code for running Docker Swarm on Kubernetes, for example, is currently PR at the moment to put it in the Docker CLI, and that you'll be able to install that on the Swarm mode stuff on Kubernetes if you've got a Kubernetes installed already. So I think that at the moment we're not working on a kind of installed experience for CE because it just seems kind of not clear that it makes a lot of sense for us to prioritize that right now. We may do in future. So I think the desktop and the CE and the EE stories are all slightly different for various reasons, which is kind of confusing. I'm just going to show you a really simple how you use LinuxKit in practice. Here's a really simple YAML file that basically just runs.
Can you make the text bigger?
Sorry.
Thank you. Bigger.
Is that big enough?
Yeah.
Okay, good. Right. So this basically the main function of this, apart from a few things like PHP, is just to run Nginx, which is our kind of hello world kind of example. So it pulls the Alpine Nginx image which from Docker Hub, and we can just build that with LinuxKit build YAML. This is the there's some expiry thing. Rotate myself. Actually, I think it will also rotate. So that's how long it takes to build, and then I can just run it locally, and that's when it's booted for you. And here we are. This has a console in it. We can see we've got network address, and we can curl localhost, and we've got the welcome to Nginx message from Nginx. So we've configured Nginx, and if you look at the processes, there's really not much running at all. So just Nginx, containerd, a random number generator support, and some logging getties. That's basically it. It just runs exactly what you say. And so I just built and run this literally in a minute, and that's an application-specific Linux distro that I built, and that's really, really, really convenient for just working with stuff. If you just want something that runs your application, it really is that simple. And then you can shut it down, it goes away, and then you can obviously deploy the same thing to AWS or GCP or whatever you want. And we try and give the kind of LinuxKit run experience is pretty much the same across all the providers. I mean, where as much as we can support it. So on Google Cloud, for example, you just get exactly the same serial console. AWS doesn't unfortunately provide an express serial console, which is really annoying. But Google Cloud, you can just unpack it. You can just get the serial console, watch the thing boot, and log in. So even if you configure it wrong, it hasn't got an IP address, you can still connect to it directly. It just uses the SSH serial console. And so that's a really simple case. If we this is not big enough.
How did you get to the serial console?
If you just do go run, it just gives you serial.
LinuxKit run.
Yeah, just gives you a serial console by default. Because the LinuxKit run is basically designed for kind of debugging and test kind of uses, so it's easier to give you a console. This is a Kubernetes install with CRI containerd, which I just run. So as you can see, if you're running Kubernetes, there's a whole bunch more stuff. I'll show you the build in a second, but we can see the name. I mainly had this here to show the namespaces, so you can see that containerd, CTR is the containerd control command, and it has two namespaces, default and Kubernetes. So we can list. Oops.
Can you make it bigger?
Sorry.
Like, it's an eye test back here, man. Yeah, that's good.
So these are the containers running in the default namespace. So this is running SSH, so you can SSH in and running kubelet. And then in the Kubernetes namespace, there's a lot of containers. That's obviously all the Kubernetes and containers got. It's running weak networking. It's running Kubernetes DNS, lots of pause containers because they've got lots of pause containers. And so you can see that the containerd is carefully namespaced between the different applications that are running, which is really convenient. And why did it make all the terminals bigger in sympathy rather than and we can see that this is logged into it. This is running Kubernetes. Let's get Sorry? That's right. So this one's running LinuxKit Kubernetes with CRI containerd test. If we shut this down, I can show you the. So this is the Kubernetes project. Basically, slightly more complicated, but largely we have most of this in this config file. So this basically tells it that we run the /kubelet, which is the basic kubelet, and that it's basically straightforward kubelet with a couple of initialization scripts to set it up. It basically just goes and looks for CNI configs and sets things up and configures it with KubeVM the first time it starts, and otherwise it's been configured once. It just runs again. So there's a few kind of little issues, and then it runs kubelet. So it's really, it's a bit complicated, and it's got a few config options, some of which need improving and making more modular, but it's really nice. It's relatively straightforward, and you can just build it like any other LinuxKit though, and it just puts everything together.
Do you mention packages and like what the hashes are?
Yeah, sorry. So yes, yeah, we like to use really long and confusing package names in this kit. So the package tags, they're actually Git tree hashes of the packages, the package code, so that every time anything changes, we actually release a new package, which is kind of confusing, but it means that it's exactly reproducible. When you build something, you know exactly which version you're going to get, rather than using latest and not really knowing. So it's a little bit more based, but it's but you're guaranteed you get absolutely reproducible builds, which is really, really useful. And especially one of the things about LinuxKit is because it actually you're guaranteed to get exactly the same thing every time. It would be kind of annoying if you built it again and you didn't get exactly the same thing. I mean, it's the whole idea about immutable stuff is you have to know exactly what you built. Shouldn't pull these images before. So yeah, if you're going to do immutability, you want reproducibility as well. And so this is part of the whole process is making sure that every time we do that, it is exactly the same. We also have a whole lot of tooling around. We build pretty much everything from using a single Alpine image as a base, and we do things like including all the Alpine. We include the Alpine package mirror inside the Docker package we use as a base to build it, so that you don't get a randomly different Alpine package from the network when the next time you build it. So again, everything's either being pulled from an exact Git tag, or it's being pulled from a local cache that's already in the image. So,
however, I thought you mentioned self-updated at the beginning. Self-updating LinuxKit?
no, you have to.
It's not self-updating.
It's not self-updating.
Okay.
You have to redeploy a new one under your own control. It doesn't do it. It can't self-update because it's an immutable system. And we basically have we have basically a whole set of stuff where we have exact versions for so you can see, so this is we have the file updated here with every single version of that, so you can look at the you can do a history on this and see exactly actually you can do a blame on each line, and you can see exactly which commit updated, for example, which commit updated OpenSSL, and exactly when, and so you can, and then you can trace this back from the tags on the images as well, so that you can see. You can see exactly which commit actually updated a particular package, which is okay. So how we can now so here's we create the Kubernetes. So we just built. Takes a little longer to start up because it formats a new disk to store the system state on. That'll take a second. It's just formatted the blank disk we gave this image, and now it's starting out. Docker, and it'll next it will bring up Kubernetes in a second. It'll take a couple of minutes. Sorry?
The experience is like Docker.
Yeah, yeah. I mean, it's the experience is designed to be as much like the container experience as you can for something that's not containers at all. It's built from containers, but it's actually it's a whole thing that runs on, boots on bare metal or cloud provider or whatever. What question?
Yeah. That's all like really cool things. But do you know when you're running Docker from Mac, you've got the Kubernetes integration.
Yeah.
Is it possible to, like here we can get into the serial console to start debugging things? Does the Kubernetes control plane run within the Docker for Mac VM that I know does exist, but I never really get to see?
Yeah, there is a serial console, which is, this is the serial console for my Docker for Mac, because I'm always logged into it. And I always have it on the second tab on my and so...
Can you make it bigger?
So it's actually it's in a slightly hard to find directory in library containers com.docker somewhere in TTY. Yeah, you can, if you use screen, you can get into it. And so yeah, this is
So I can,
This is
Can you make it bigger?
yes. So this this is running Cube, so it's got the Cube services up and the Kubernetes running there, and you can I'm putting in where the sorry. I'm clearly this runs set up in a weird way because I can't see any containers running, which is obviously not true.
LS containers?
Oh, sorry?
LS containers, wasn't it? Just the directory where the process is.
Well, you know, but I want to, I can see what.
Should we be running this inside the LinuxKit?
Possibly in the
On the host.
you can't talk to containerd from the host. So you can only do it from the, I can do it Prometheus from there, which will give me all the because I didn't tick the option in the config screen preferences for. I took the one for show system containers advanced, so that's why I can see all the system containers. But yeah, you should be able to talk from containerd from here, and I don't know why. I suspect I'm in a different namespace and I can't see anything, which is annoying. You can from from the one I just built. But generally, the setup in the Docker Mac one is generally pretty much the same as the one we have in the open source one, but they have every now and again they change some things and it's a bit weird. But I suspect they put the console in the namespace, which is annoying. I'll change it.
thank you.
So the version of Kubernetes, will it be 10, the specific version of Docker for Mac? So say you want to use a specific version of Kubernetes on the Docker for Mac, it's going to be configurable. Just going to get like say.
No, you'll get. We're just going to show the latest version with a small lag. I think again, if you want to do weird customizations, we want to make the open source one really easy to configure for doing weird things. I think that the Docker Mac is supposed to cover the sort of 95% use cases and be really convenient, but not be too configurable because it's just too complicated for people to like. Most people don't care. But if you really care, then yeah, we want to have it so you can run something that's as easy pretty much as just a command line thing you can run that will run a version that you can customize with the config file. It's pretty easy to change the.
So how does it compare like with Minikube? That's what I'm trying to understand. Like, why would they use Docker for Mac with Cube instead of Minikube, or the other way?
Do you want to answer that question?
Sorry, could you repeat the exact formulation? Of
So now, right? I download Minikube.
Yeah.
And I'm good to go.
Yeah.
In the future, are you guys suggesting we shouldn't do that and we should use Docker for Mac with Cube? Are the use cases different?
So I guess use cases very much similar. There are a few advantages in Docker for Mac, and generally using Hyperkit and such. And we potentially looking to contribute improvements to Minikube as well.
There is a Minikube X-High, not X-High, what's it called? I can't remember that. The native thing for
Hyperkit driver. Yeah, it's currently very experimental, so we'll be looking to improve support for Hyperkit. And one of the things in Minikube right now, it uses Docker Machine, and Docker Machine hasn't seen Docker Lib Machine library, right? Which hasn't seen any new features recently. It was basically maintained but not worked on as such. So we're potentially looking to contribute removal of Lib Machine and improvements to Hyperkit support, and
they'll probably merge at some point, I assume.
That's right. That's right. Yeah. But like, if unless you know, you have some hard dependencies on Minicube's features. People desire to use a version of Minikube that I don't know, maybe you hack or you build yourself or whatever, right? Or you contribute to Minikube or anything like that. You use Minikube, but otherwise, why don't you?
I mean, I think that in our experience, a lot of people use Minikube and Docker for Mac, and that's kind of really weirdly complicated. I mean, whereas when you're going to do the option, one thing that will do, or hopefully for most use cases, everything you want in one tool, which I think will be incredibly convenient. But yeah, I mean, there are lots of other use cases and lots of kind of things that people will want to customize, but you know, we've got the LinuxKit upstream, which is a great way of doing that as well. So, yeah, I mean, we spend a lot of time with Docker for Mac, you know, working on things like the Hyperkit integration and the Hyper-V support. The Windows support in particular, I think is, I mean, we spend a lot of time working with Microsoft on Windows support because they're really keen on having desktop support, and they really want desktop support for Cube as well. And I think Minikube is mainly developed on Mac. But most people use VirtualBox, and VirtualBox is horrible. I mean, I think that
the nice thing now is like I can Minikube is almost like an add-on, so I can use whatever Docker for Max version I want. Then I have clusters of the Kubernetes 1.7, 1.7.5, 1.8. I can install different versions of Minikube, and I can test against it.
Right.
It's not using Docker for Mac, that's what.
Yeah. So I think your use cases, it definitely falls into the unusual use cases, and I think that, but yeah, we definitely, I think, you know, LinuxKit would be something you could use for that as well. Once it's slightly easier to use on a day-to-day basis, and then which should be in a few weeks.
Docker for Mac's got a load of optimizations to make things like the file system work nicely and well. This is me not understanding the Docker ecosystem. Is that in Hyperkit? Or
the file system stuff we haven't open sourced yet. It's a separate project. Probably will be open source at some point, but I have no idea when. It's still kind of under development. But all the other pieces they're all separate projects. So there's VPN-Kit, which is the networking piece we use. So that's all open source, and that's we added some Cube support for that, for doing port publishing from Cube, for example. So that's now in the VPN-Kit repo. And yeah, so it's all quite small. Hyperkit's only got the basic virtualization piece in it, and then but it has some hooks where you can integrate VPN-Kit, for example, for doing your networking and things. So it's kind of yeah.
Kind of led me to think, building on what he was saying, if you wanted to run Kubernetes 1.7 or something, you could build a LinuxKit, like the VM that we've just seen there built. I guess we could go and build that instead of using Docker for Mac.
Yeah, absolutely. Yeah. So that's what I mean by that. We just want to make that experience much easier. So at the moment, we've got this little kind of makefile and boot script, but it's actually still really inconvenient because it doesn't do things like the port forwarding and things like that, and the setup. Basically, the port forwarding actually it doesn't do, but it could do, because there's actually we integrated that a few weeks ago, and so it's into the LinuxKit run script. We need to tidy up the cert generation stuff, because at the moment you have to copy the certs from inside the host that is generated onto your machine to talk to it, which is really annoying. And I don't like this. We've got a really hacky solution on Docker for Mac at the minute, and it is tidying up, I think. So I've been meaning to just tidy that up and add that code in there as well. So, because those are the two things that are basically annoying at the minute. And the port forwarding one we basically got fixed for, so it should be easier. And the cert generation one, I think I decided we should generate the certs on the host and pass them to the machine. At the moment it's the other way around, which I think is stupid. Pass them in as metadata maybe. So yeah, this setup we've got to be complicated. So once we've done that, it should be just a matter of build and boot it, and then you should be able to just use it and just just add it into the config and just use it. So that should be much easier. Yeah.
So you mentioned before that LinuxKit can target Raspberry Pis. Would this Kubernetes on LinuxKit work also on Raspberry Pis?
It doesn't yet, but only for really bad reasons. In the we're using upstream Kube admin, and that's only got support for pulling stuff from Google Container Registry, which doesn't have support for multi-arch images, and it doesn't have ARM64 builds, which we're only supporting ARM64 at the minute. But I was talking to one of our developers this morning who said he happened to be working on ARM64 support, so I was trying to nudge him towards doing that. So we just, it's really kind of minor reasons. It just needs a few patches around the place probably, but it's there's no fundamental reason. And we worked with ARM a few months ago basically to do a full ARM64 support for LinuxKit, and it's really straightforward. You, on an ARM64 machine, you run exactly the same commands and it builds you an ARM image. It's really, really simple, and then you can just run everything and push it. So we use multi-arch Docker images, which are really, really straightforward. So that basically we build everything at the moment for ARM64 and AMD64, and we can add other architectures now, obviously. So that's really kind of cool because there is no difference in the code at all between different architectures, and the Docker images are all the same. Any of the LinuxKit images you see, you can just pull them on ARM as well. So it's the multi-arch support's really, really good now. It took quite a lot of time to get it to work, but now all the infrastructure's in place. We build all the kernel. We've got kernel configs for ARM64. I think it's all there.
Regarding LinuxKit deployments, specifically targeting AWS, I'm curious what happens with the metadata networking endpoint that we often use to configure things like.
Yeah, we have a metadata package for LinuxKit that has support for all the cloud platforms and a few other sources like it can take locally mounted ISOs and as well. Like basically has a sort of general interface where it basically takes the metadata and user data and feeds it into a standard file system layout that other packages can then use. And it's got a fair amount of customization for AWS, GCP, Packet, and a few other providers. So it's kind of
the idea being you've already thought of this is a solved problem.
It's I mean, you might have to customize it if you want to do. I mean, I think it's missing a few things. I know, for example, it only, for example, will pull SSH keys for one user on GCP because so it's got these providers at the moment, which covers many use cases, but not every one. But you can kind of extend it. It's just a little program written in Go. It's easy to extend if you have some weird use case or we haven't.
Not weird. I'm interested in the idea that we could replace Packer built Kubernetes with LinuxKit deployments.
Yeah.
Appealing.
Yes.
But all of our applications use assume role. In order to use assume role, you have to have access to the embedded endpoint. You have to go through the assume role that obtains permissions. The application needs to run.
Yeah.
So, that's what I was curious about.
Yeah, I mean, I think, we have a lot of people who are interested in replacing Packer with LinuxKit because Packer just takes such a long time, and it's
slow to do.
Yeah, Yeah, and it's very indirect. I mean, one of the requirements for LinuxKit was that you should be able to build it locally on it, in a CI pipeline without having to boot a machine to run it, to do anything. So we, for the cloud providers, we basically build a local disk image and then upload it to a storage bucket and use the conversion functions on there, which are pretty, which is just much simpler because then it's just there and done, and you've got an AMI boot.
There are a bunch of other theoretical advantages, but kind of very practical advantages that you don't have an upstream dependency, you don't have like a base AMI of some sort that you depend on, right, or a chain of base AMIs, whatever those may be. Kind of you full control of what goes in.
Yeah, it's brilliant.
Yeah, not really directly related, but I'm just curious, what happened to Docker Swarm? Because that went from being like a major hype thing to, we're not really doing this anymore.
No, we are. I mean, we are basically, we're supporting Swarm or Kubernetes for customers, depending which they want. I think we have a lot of existing customers on Swarm who are happy with it and are going to stay using it. But we have a lot of people who are only interested in Kubernetes, so it's, that's a choice. I think that apart from someone was asking about Windows, I think Windows support Swarm is currently much better than Kubernetes. But I think they're also very different in other ways. They have quite different security profiles in terms of what you can, what the auth models are, and some people kind of prefer the Swarm one. I mean, I think that obviously Kubernetes is something that a very large number of people want, and and so I would probably expect more people to use Kubernetes than Swarm, but but we haven't dropped support. We're still supporting it. We have commercial customers using it in large scale who we're still going to carry on supporting.
How about Compose?
Yeah, so Compose, so we've added basically a Kubernetes API extension of running Compose files on Kubernetes, and that will be launched, I believe, it will be shipped with Docker for Mac, as that's be the first preview of it. There's still some, but basically it's an API extension which understands Compose files and will create pods and services and so on from the Compose file, and then when you update the Compose file, it'll see what needs to change to redeploy that. So I think that that basically makes kind of Compose a kind of realistic option to use with Kubernetes without having to do a one-off file conversion that like Compose with a K does. I think it should be simpler. I think it's I think that I hope we can get people who are using Docker Mac, a lot of whom are heavy Compose users, to use that with Kubernetes and see that it works. I think it'll be a good intro. I mean, I think we've got an interesting situation with a lot of developers who we're going to expose to Kubernetes the first time by shipping it in Docker Mac, and I think that'll be their intro. We're currently working on all the documentation for the Compose feature in Docker Mac and Windows, and it's going to be an interesting thing because I think a lot of these people, their organisation may use Kubernetes, but they may not have had much exposure to it directly themselves, and I think these things are going to be really important for getting these new users introduced to Kubernetes and how it works. So that's kind of the Compose story, and obviously they don't have to use Compose; they can just use Kubernetes natively as well, or whatever else they want to use.
The feature parity, how of converting Compose files to native Kubernetes abstractions. Did we see any?
The main different. The main thing that's kind of different is the network, the model of networks that we introduced in Docker for having segregated networks as an access control thing. And I haven't been working on this, so I don't know what the current status of emulating / converting that actually is. I should do. I should know the answer to that question, but I don't.
We will have the right engineer on the booth, so please stop by.
But I think it's yeah, that's the main thing. Everything else basically just works because of the concept. But the network isolation model for Swarm was very different. And so yeah, that's the one thing that I don't know exactly what the status is. But everything else should work. I suspect it might work, but not actually enforce isolation, because network isolation is kind of optional anyway. So it's kind of so it may be that currently you can connect to services that you on different networks. I'm not 100% sure.
So, I kind of briefly talked with you this earlier. So, I've been working with Docker personally for about a couple of years. So, more so with Swarm, and now I'm just running Kubernetes on my own. And I just messed around with the Minikube on my Mac until I learned that it's going to be, part of the Docker Mac. But my company, they're basically Windows dominant, more so than anything, so I was going to introduce them to use containers on Windows. Would it have like the Docker for Windows with Kubernetes also part of the too?
Yeah, it's going to ship slightly later than the Mac one. The Mac beta is going to be first, but yeah, it's also going to be on there.
I know Windows seems to always lag behind.
It's basically the same. It's basically the same code. There's not really any difference. So I think it's really just because we just wanted to release one at a time, just from the testing point of view and things like that. So if you run the LinuxKit upstream code, it runs just exactly the same on Windows as it does on Mac, just using Hyper-V. There are small kind of differences around how things like networking works, but basically all the code we use is the same, and LinuxKit runs absolutely fine, just like on a Mac on Windows. So it's all pretty portable, and the Kubernetes stuff is obviously inside the VM. There's some complications around running Kubernetes with Windows containers rather than Linux containers.
Yeah, I heard that they still have open issues with config maps and the security with the Windows, and also trying to finally having the Windows to work in pods, having more than one container in a pod for Windows. So that was some areas they're working on. So
yeah, it's really complicated as well by the fact that there's actually two different kinds of Windows containers, because there's the native ones and there's the Hyper-V ones, and they have different properties, which is so some of those things I think that and then they're working on a new version of for Linux containers on Windows as well. So yeah, it is definitely there are definitely some bits that are I mean, Microsoft working on it really hard, and they have, I think it's getting there, but yeah, there's a few complexities around the Windows.
It works really well on Docker Swarm, and as you said, Docker Swarm is going to continue to be there. Myself and some of the other Docker captains have written blogs about running Windows containers with Swarm, with Docker, and I think it just works really well at the moment. And I spoke to some guys at Open Source Summit who are trying to get it to work with Kubernetes. I think it's just too early. It will get there.
I think it's too early, but I mean, eventually it'll catch up.
I would try with Swarm and just prove stuff out and get a bit of confidence.
Well, because I was watching the Docker Con, and the guys were talking about how, I'm trying to train of thought, how It works beautifully on the Swarm. I agree with that. It's just the Kubernetes part of it. So I'm just trying to get my company to try. I'm trying to think ahead, play with the Swarm part, and wait for the Kubernetes later on because it's not really ready yet. But
yeah, I mean, I think there's a lot of work going on. It is getting there pretty quickly, and yeah, we spend a lot of time trying to solve it. But yeah, there are.
Oh yeah, it's the MTA program that you have with Microsoft. That
yeah,
the MTA that you have with them.
I think we've got to wrap up now. So I'm around if you want to ask more questions. And I'm around all week as well, so you can catch me at, I'll be at the Contributor Summit tomorrow, and I'll be on the Docker booth at various, I think most morning, if I remember rightly. Schedule, I'll be
Two more short talks. If you're interested in Prometheus things and serverless things, some of you are. But before that, restroom break. Yes. You're glad to thank me there.
And like being in
haven't heard a lot about it. You want to do the conversion
keep using like class and throw away.
It's not a large one, it's not small, it's kind of
No, that's exactly right. I think we're still working on what the story is. I'm pretty much on an attendance. We have a like you have to always specify how many yes, that's
it's not a problem. And working on something where the main reason about that is the standard
so the reason why we had you're right, they're coming from the land lower, but they're actually having
That's
the first meetup they had was around but at the same time, you don't want to be something where things are running. I know that technically there isn't but you want to.
What?
Let's after this, I'll
For now.
Right. It's a different use case I learned that's like AWS.
Alright, so we've got two more
Sorry,
talks.
let's talk about it.
First of which is really just probably more common relief is what I'm providing for today. I think I mentioned earlier I do take credit cards. Unlike the unfortunate souls on the street, there's no excuse. I do take credit cards. Yeah, okay. Very good. Well, that had the effect of starting that. Yeah, okay, we've got a couple of just lightning talks. For the most part, as we welcome Justin in and the rest of the crew, we wanted to not leave them as the sole speaker standing. So we just reach into the bag of tricks and pull out a couple of recent innovation projects that my crew at SolarWinds has been working on, or some areas of focus. And so, if it wasn't obvious from those who raised their hands about being in the Czech Republic next week, that's the SolarWinds crew here in the front row. I'll be there as well, wrapping up a long event KubeCon, Czech Republic. On that, so we wanted to talk two things today. Girish is going to talk to us about serverless here in a bit, and so of course he'll summarize all that in about 10 minutes. No problem.
Yeah, I hope you guys are drunk enough,
Yeah. The other thing is we'll talk a little bit about Prometheus. I'm going to call on Trevor Rosen, the principal architect within the group, who actually took on this innovation project and took a focus on Prometheus. Prometheus, many of you, some of you are extremely familiar. Anybody not familiar with Prometheus? Anybody kind of doesn't know the space that is? Yeah, very good. So monitoring time series. Data, so very popularly used within the cloud native kind of Docker ecosystem for monitoring ephemeral things, monitoring containers, doing a couple of things very well, and sort of ardently the maintainers, all of which friends, Bjorn, Fabian, Brian, who am I missing? Julius. I've got a pretty tight focus on what it is that Prometheus should do. It comes in a couple of binaries. Today I intended to kind of talk to you about Alert Manager and remote storage adapters. We're going to skip the Alert Manager part and talk just about the storage adapters part. So, hey, if you haven't heard enough about me already, then get ready because you're going to hear more. So hey, I'm full-time focused over at SolarWinds. Wear a couple of other hats, run a couple of meetups here in town. The two that you're here at today. I occasionally do some analysis and podcasting for the News Stack. I write the Network World, authoring a book currently with Bill O'Reilly. I'm active in the CNCF. I'm a Docker captain. I'm joined by Alex Ellis, another Docker captain in the room, and some honorary captains, and Justin. And generally try to make myself a nuisance anywhere I go. Those of you who had the fortunate mark of interacting with me previously, you know that. So anyway, harass me if you don't, online if you don't do it in person, and talk to me about why does I have a blank slide. Hey, who knows?
I thought that was my bio.
Yeah, and so actually, maybe we should maybe talk about.
No, I'll be just look at the code.
So by the way, SolarWinds is headquartered here in town. I've been there a little over a year. It's been kind of refreshing to me to work. I've been at Cisco and Seagate most recently, leading large teams there. Girish was unfortunate enough to join me at Cisco, silly enough to join me at SolarWinds. I have no idea how the guy came over, but it's been refreshing to just kind of work in some small teams on some innovation projects. We're going to talk about the innovation project. Who's heard of SolarWinds software? A few of you guys are in Central. Very good. So monitoring software, generally kind of management software. 38 products, a little over 1,000 software engineers. It's a smallish, medium-ish type company, like just doing well. I mean, kind of the thing there is like affordable, powerful, easy to use. Turns out if you push licenses in high volume, that really adds up. So doing well around network monitoring most prominently. But it's our one of our SaaS portfolios, our cloud offerings that has Pingdom, Papertrail, Vibrato. And we recently announced last week a new product, AppOptics. It's a combination of our distributed tracing capability. If you're familiar with Zipkin or Jaeger or the sort of X-ray, things of that ilk. It's that plus something kind of similar to Prometheus. And so Prometheus has been a special interest of ours in terms of how it is that we've got customers that are using Prometheus and how it is that we can add some value in the Prometheus world. But first, is that big enough? Everybody? All right, okay, I'm just harassing. So we're not going to talk about Prometheus. I did say it was going to be a lightning talk. We're just going all joking aside, if you want to know some things about Alert Manager, there's folks like Ilya in the room that can tell you about it. As well as I gave a talk this last KubeCon EU on Alert Manager. We went into it a bit, so go check that out. But so the storage adapters, like I said, Prometheus does some things well. The team behind it has decided that one of those things they're not trying to necessarily solve for are things like long-term storage of the metrics that it scrapes and collects and stores. It does that locally, and most prominently, most recently, it's done that in a 2.0 release. It's probably it's probably the only CNCF project right now that's at like a 2.0 kind of level of maturity. So kudos to that team. What they've just said that they're not necessarily trying to address right now is sort of scalability and durability of that local storage. So Prometheus scrapes targets to use the Prometheus nomenclature, collects that those metrics, persists things. It used to be in 1.8, it would persist them in memory. It still persists these things in memory. It used to use level DB. Now it uses custom-written data storage systems that apparently is about 33 to 50% more efficient in the way in which it's able to compress time series metrics. And it writes them to disk in directories that are about 2-hour windows. And within those directories, you'll find a write-ahead log, which is there in case of failure, in case Prometheus goes down and needs to come back up and read from that write-ahead log to then reformat those time series metrics into chunks, and it stores those, and then it has an index file that contains metadata, labels and things about the metrics themselves, the metrics names. So it's this is kind of a quote from Prometheus.io itself. Prometheus provides an ephemeral sliding window of recent data. It's kind of the focus. Things that are much further in history aren't necessarily Prometheus provides for. You could store millions and potentially years worth of data on your local disk. It's just that depending upon your durability and availability requirements, maybe you need something else. So the team Prometheus team has come up with the answer there, or how they're presenting the answer, which is through remote storage adapters. So Prometheus is able to interface with entities that go out and create an adapter to suck in those write samples and store them wherever it is that they like to store them. We'll show you an example of that. Prometheus is also able to, so one of the claims to fame for Prometheus is its own query language, PromQL. It is inspired from kind of the query language used in Borg Mon actually specifically. so it's able to not only send, not only it keeps track of the metrics in memory, persistence, and local disk, but to the extent that you've registered a remote storage adapter, it'll also write those to that remote storage adapter. If you're writing a query that retrieves metrics that are further back than it has locally, it can pull those from that remote storage adapter. You just need to be aware that, like, for PromQL, when you write those queries, it can only, again, if your query is pulling too much data, it has to stuff all that into memory and compute that. So Trevor Rosen here went out and did really an implementation of a remote storage adapter, which Trevor can tell you how big of a piece of work that is. It's probably on the scheme of things, not moderate to non-moderate expense. So it does that. It fulfills this intermediary layer. It receives write samples from metrics from Prometheus. It really performs two things most prominently. The first of which is sort of this translation between Prometheus constructs. Prometheus has labels, and you're able to assign multiple labels to a given set of metrics, a given time series. And you want to do that because you want to provide dimensionality to your time series metrics and slice up that data in different ways. Well, the product that we have called AppOptics doesn't have the concept of labels. It does have multi-dimensionality to its metrics. We call those tags. So it's a different system, so we store them a bit differently. And so that's in part what this adapter does, is translates between the two. And the other thing it does is kind of optimizes the efficiency by which it pushes those metrics to this remote storage software, and that does that by batching up those writes, those posts out to our /v1/metrics endpoint. And it does it in sample sizes of 1,000. Let me show you what that looks like. It's an open source piece of software. It's available here. We've been attempting to dog food a bit internally. Thank you, Alex. Let's see if I can show you guys what that looks like.
Lee, what is AppOptics?
Yeah, that's thank you, Alex, for a beautiful transition. Let me see if I can show you. So AppOptics is a SolarWinds product announced fresh as of exactly 7 days ago. Simply, it's provides custom time series metrics storage, dashboarding, alerting, and charting out of the performance of these things. There'll be a lot more on this.
Also there.
So that's half of what it does, if I can find a good dashboard. Works. I don't know. I'll stop on this one. Anyway, so it, great. So it's monitoring Docker hosts, various metrics on the host. That's half of what the product does. It provides alerting and charting and that type of thing. It also does distributed tracing. So if we were to go in and take a look at it.
Open source, like all those dashboards on CI?
No, so this particular one is the storage adapter that we were talking about before is open source. This particular one is a SaaS offering from Columbus and so. Yeah, so it's kind of an enterprise class Zipkin or Jaeger, if you will. The other part of what it does is it's an APM solution. It does distributed tracing. It auto instruments most languages. And is aimed towards the developer. So here's a dashboard, kind of your app. And then to the extent that you want to look at a heat map of the trace requests that have happened, you can go in and see, get a full set of spans and segments and see, what aspect of your app is taking the longest. Anyway, that's what AppOptics is. That's the longest product pitch I've ever given. So let's get back to that. So anyway, so here's a dashboard that's showing metrics coming in from that Prometheus remote storage adapter. So anyway, we took this on because we have customers asking for some assistance with long-term storage, and Prometheus is commonly used with Grafana or other dashboarding projects, and that's in part what AppOptics provides. So.
And Influx on the back end sometimes too. So if you look at other remote storage adapters like the one that's in the Prometheus, I think Repo itself released an example of sending this data to Influx. So this is just like you want to send your data to a SaaS solution that helps you slice and dice the program and all that other stuff.
So enough with the product stuff. Back to it. Yeah, very good. Well, that's it. So hey, lightning talk. The URL is here. There's an overly good-looking guy who apparently only has one shirt. Very good. Well, thanks for hearing me. Welcome up, Girish, Ranganathan.
Come on, I think you guys should be drunk enough now. Okay, cool. Hey, Max is here. Hey. So this is again, just like what he said. It's a very quick intro to CNCF, Serverless, and Nuclio. And I am Girish. I work at SolarWinds. I'm part of Lee's team. I'm from Canada. So this is like a very high, table of contents. So I'm just going to touch on what CNCF is, the Serverless work group. Of course, there are other work groups, but since of relevance, I've just chosen this Serverless. And then of course, like Serverless, and again, Serverless is a very broad term, and the thing of interest here is the functions as a service. And then just a mention of the pros and cons of Serverless, and then just touch on Nuclio, its complement, and one of its core, which is the function processor. And of course, some highlights probably at the end of the slides. That's pretty much the talk. So CNCS and the Serverless work group have the link at the bottom. So it's open. People are welcome to join if you already are not part of it. So what is CNCF? I think probably we would have been a better person to actually present this, but so CNCF is actually a group which is focusing on stewarding projects, foster the growth and evolution, promote the underlying technologies, and make the technology accessible. Of course, it's huge. So there are a lot of members. The idea is not to overwhelm people here, but I'm just trying to give you a high-level view, a telescopic view of members who are part of CNCF. So as of today, I think there are 14 projects which CNCF has under its umbrella. You would probably be recognizing some of them, like Kubernetes, Prometheus, Fluentd, Open Tracing, Jaeger, TUF. Some of these were mentioned in the other talks. I'm just trying to correlate them. So these are some of the popular projects. Here's a general landscape, and it also tries to highlight some of the the CNCF projects here. Again, not trying to overwhelm. Just trying to give a perspective. Working groups. So CNCF has multiple working groups, just like I mentioned earlier. It has the continuous integration, the networking, storage, and the Serverless. Again, for this talk, the Serverless is of interest, but then the thing is, Serverless is kind of new, and it's kind of the most active, is what I hear. I just became a member of it. So the purpose of this work group is to educate the developers on the Serverless architectures. Determine what CNCF should do in the space, in the sense coming up with specifications. So it's still a work in progress. I would be showing you a link to a working draft of a document, which you guys can definitely be part of and contribute if you're interested. And of course, recommend involvement in specifications and projects. So that's what the Serverless group is doing. With CNI and storage, they already have the specifications like the CNI and the CSI. So those are pretty popular. The CNCF Serverless work group. So right now, just like what I mentioned, it's working on a white draft. a white paper, which is like a draft of what serverless technologies are probably working on at the moment. They are working on defining, or a specification for defining what an event should be, like an event object should be like across the board. And of course, there are other areas. So, what is the white paper? It actually describes what the serverless platforms are doing today, trying to come up with a common list of, with a common vocabulary. It highlights the common use cases where it has already been proven. That's what it's trying to do today, or it already has it. And then it tries to kind of help explain what the serverless is and tries to differentiate it from the other, the cloud paradigms, like PaaS and container orchestration. And of course, generally describes what a serverless system should do. The other part, which is the event specification. So there are multiple things going on. This probably might be dated, but the few things are like the cloud native event mapping, open events, and cloud auditing, data federation. So these are some of the specifications that are in the works. Other areas, it's trying to maintain a matrix and landscape of serverless implementations and features. Again, this is more specific to the work group, but I kind of presented the landscape, so it's trying to kind of have a overall view, overarching view there. Produce additional documents and samples to educate users of the apps. Again, this is probably not just the serverless group's focus, but it's in general the CNCF focus. Document integration with other projects, and we actually heard some mentions that there are initiatives for groups to work with one another. So that is kind of one of the CNCF's focus. So that's pretty much it. And again, I think one of the things, the last thing is come up with declarative packaging format specification. When I get to Nuclio, I would be mentioning that. You kind of can produce different binaries or containers or things. So I think the CNCF would actually kind of help there as well. So that's CNCF highlights. If you guys just if you guys are not part of it, if you're interested, please feel free to join.
And Girish, just on that, we've got a couple of folks in the room that are active participants in this working group, and I just want to highlight one in particular. It's Mr. Mark Peak back there.
Hi everyone.
He's the steward of Mark.
Yeah, so I'm Mark Peak with VMware, and I helped kick off the working group for serverless. It's been a great process that we've had with all of the major vendors coming and joining in with us, talking about what is serverless. In fact, Doug Davis from IBM and I are giving a talk on state of serverless at KubeCon, so I hope everyone shows up. It's going to be a lot of fun as I, kind of go through the windy path of how to define serverless that will satisfy both public cloud's view of it and the rest of us. So should be fun.
When is this talk?
Awesome.
It's on Thursday at 11. And a shout out for Alex, who will be presenting, I think, at 2 o'clock on Thursday.
Yeah, so going to be speaking about OpenFast, which is a community project. It launched in May and already has 8,000 GitHub stars, 65 contributors from all around the world. It's very active, and people are taking it to production with Docker Swarm and Kubernetes. So come and hear more about it, openfast.com, or Thursday 2 p.m. More than welcome. I actually have some stickers, just a few here if you want them.
Excellent, excellent. Cool, awesome. Very nice, thanks. Okay, so what is serverless? I know many people already have some gear deep in. So this is so it's a lightning talk, but just it's a knowledge share session. So what is serverless? I have the white paper document, which I mentioned earlier, the CNCF link at the bottom. So it's a short link, but it's a Google Doc. So serverless computing, it's a concept of building and running applications that do not require server management from the developer's perspective, of course. Consists of, again, when I'm talking about serverless, I'm more inclined towards the functions as a service, right? So So it consists of event-driven functions that respond to a variety of triggers. That's usual, like triggers like HTTP requests, message queues, you name it. And it actually provides a Now this is the part of it. So when we're talking about serverless, so there are two personas as the document would actually present itself. One is the developer side of it, and the other one is the provider side of it. So developer side, you write functions, you deploy, and expect it to be taken care of. So now this is the other side, which is the provider side, where the provider is supposed to actually provide a platform which takes care of the rest for you, which is like triggering the trigger to function logic, information passing between functions, the provisioning of the containers and runtimes, auto scaling, identity management, more like logging, so obviously pros. It is the lowest requirement for infrastructure management among cloud native paradigms. You don't have to worry about the operating system, its management, the runtime, etc. Everything is like you just define it. Usually, most of the systems they help you define it in a specification document, and then they take care of the rest. The automated scaling, load balancing. So everything is pretty much taken care of. And the most interesting one is actually the last one, which is no cost when I go to customer. That's an interesting one for the customers. Cons, it is rapidly evolving. There's no standards, so that's what CNCF is actually trying to help with. Since it's rapid, a lot of players are in that area. So the documentation is not, well, I wouldn't say it's a case with everything, but on an average, mostly the documentation definitely has room for improvement. Samples, tools, best practices, that's obviously in the works. Sometimes it's challenging to debug because the environment is not in your control. So because you just write a piece of code like a function, expect it to work, and that stuff. Potentially slower response time because in some cases, the cold start kind of hits on performance. Lack of standardization and ecosystem maturity. Potential for platform lock-in. So it's not like you write one set of functions and expect it to work across. So mostly, when you're working with Lambda, for example, it's a lock-in. So that's kind of an example there. Of course, serverless is not a fit-for-all solution. So you have to pick and use it in the right places, the right way. So one example here is when you want to run a socket, WebSocket or something that's not going to be an excellent fit there. So those are the cons. Here's a nice picture I borrowed from the site at the bottom, I'm just shriveling. This is the way the systems have been evolving from monolith to microservice to functions. Some not necessarily disorder. Again, this does not mean people are completely transitioning away to functions as a service, but mostly it's a mix and match between microservices and functions. But again, it doesn't mean you cannot totally move to functions. Yeah. This is, I know this slide is kind of too short. I'm just trying to hit on some of the popular ones. Amazon Lambda, Google Functions, Microsoft Azure Functions, Apache's OpenWhisk, Nuclio, which is what I'm planning to touch next. OpenFast, Fission. Actually, so the thing is, this slide is kind of too short. I didn't have much time to actually kind of do more and in a sense collect more. There are a lot of platforms out there which are working in this area serverless. I think that's the name of a node-based serverless platform. So there are a lot of people who are in this area. It's very hot, and I'm not trying to favor any platform at this moment. This is what I'm learning. So I just hit on Nuclio, so I'm just planning to present that. So I'm not trying to favor anything, but everything is awesome. So jumping on to Nuclio. So here's a link for the GitHub page to Nuclio at the bottom of the page. So this is a logo from their site. So what is Nuclio? It is a serverless platform for real-time events and data processing is kind of how they have phrased it. It's good. I got to play with it, so it's very interesting. So what is Nuclio? So they claim that it's comprehensive, open, portable, super fast serverless. It's created by Guasio. Now, the good thing is that it actually can run on a variety of platforms, like Raspberry Pi, Docker, Kubernetes, GCE. These are the ones for today, but they are expanding. They're working on the other ones, so so eventually it's going to be support more platforms. So as a result of that, also packaging. So you can actually package Nuclio as a standalone binary or as a Docker container, so that for Raspberry Pi, standalone binary is actually better. So here's an a general architecture for Nuclio. There are some interesting components, so you can see the pluggable sources on the left, the pluggable data services on the other side, and of course the interesting piece is the function processor. And I'll talk about the function processor a bit more next. And then there are some common elements in the platform, for example, the dealer, controller, builder, and of course, the platform at the top, at the bottom, so essentially for interacting with the underlying system. And of course, there are multiple ways we can interact with the system. One is it does provide a playground. It is like a user interface. It's very easy to play with. So they also have some samples, so you can actually start off with some. And then you have the new CTL, which is like a command line thing. So it actually helps you to build, deploy, and look at what functions are deployed, and it's just fundamentally a CLI. And then the image repo. The builder, what it does is so we give it the code and the specification, and it actually builds it and publishes publishes the artifacts to the repository. So that's what the image repo there is. Dealer has an interesting role. I will see if I can actually hit it later. But a dealer is more like when there are a lot of events, and when we want to manage data across functions for scaling, dealer is actually a piece which kind of plays this scheduling role, and also it does more in the sense it actually ensures that the thing works, there's no duplication, and it also handles failures. So that's kind of what the dealer is. And the controller is like the Kube API server. So it actually accepts the specifications and the function code, and kind of delegates it and runs the functions, and so that's what the controller is. And inherently, they have actually brought in support for working with Prometheus, for monitoring. And again, the platform supports or provides logging, so we can actually, I think it's plug and play. So as the image shows, you can actually set Elasticsearch. Pluggable data sources, that's another interesting piece. So when the function is executing, it would be nice for persisting data. So that's kind of what the pluggable data source is. What the function processor piece does is it actually abstracts the backend. That's one thing, so that they have multiple classes of backends, so that you can actually interchangeably use them without having to change the code if you use their interface code. So that is one of them, and also it actually when the function is defined, it actually establishes connections and kind of injects it into the function as part of the context, so that you don't have to initiate a connection and kind of spend time on that. So those are the kind of main pieces. Kind of touched on them. So the function processor, controller, the playground, which is the UIPs, the builder, dealer. So these are all the general components. So now kind of looking into the function processor. So the function processor has multiple components. So I'm just going to go to the next slide, which has the background. So the function processor, it actually has several components inside of it. So the first one is the event listener for based on the triggers that are configured. The event listeners are the piece which kind of gets the data and delivers it to the function. And also it's responsible for sending the data back, whatever the response is. It kind of handles failure in case the function fails, that kind of thing. Then the other thing is the runtime engine. So when a function is initialized, the runtime engine is initialized, and depending on the chosen runtime for the function, it sets things up so that everything is ready. When a trigger, when an event comes in and a particular function is triggered. Data bindings, I kind of explained it before. You can see the data bindings that are supported. So those are the classes like file object, DB, stream, messages. So those are all pluggable. So so that so when a function is initialized, it actually establishes connections and provides the connection inside the function when it's executing. The event sources, there are 4 types of event sources: synchronous, asynchronous, stream, and polling. Synchronous is HTTP requests, so that you can actually define triggers, which are just HTTP requests. Synchronous, RabbitMQ, message, the MQTT and NATS, obvious choices. Stream, Kafka streams, Kinesis are obvious things. And polling, so polling also involves not just DB and file changes, but also ETL jobs when there are shards of sharded backends, sharded data stores. And the control framework, that's the common piece which actually provides the logging, security, monitoring for statistics, and things like that, for function. And of course, so the platform supported are the bottom. So again, from the previous slide. So that's the function processor, and every function gets its own function processor, so that it also takes care of scaling it. So these are the event sources, kind of a more diagrammatic representation of it, so it gives a better feel. So the HTTP request coming in, the API gateway, and then functions are actually more based on request response. And same thing with asynchronous message queues. So the specification for the function would actually contain all this. So you can actually specify the message queue URL, whatever is needed. The same thing holds good with the message streams and the calling. So these are all the event sources, or the event source types Nuclio supports. So that's a highlight of Nuclio. So the highlights, it supports real-time processing of data. Little CPU overhead and maximum parallelism is what they're claiming. It's easy to debug, multi-version CI/CD pipelines. They also support versioning of functions. So when you're defining a function, you can actually tag it so that you can use the same tag. Multiple versions of the functions can actually be run at the same time. So you can have one endpoint, point to the production version, another to the beta, and so on and so forth. So that's kind of a nice thing. Pluggable data event sources with common APIs, so that you can swap them without having to touch the code. And it's portable across platforms. So those are the highlights for Nuclio. These are the information sources for CNCF work group, the white paper, the Nuclio. It's open, so you guys can actually access it later. That's everything. So just try to hit on some of these topics. Of course, they are very huge topics, but so just try to keep it as short as possible. Thank you. Okay, now they're wrong.
So I did call out a couple of folks in the room. This is something of a unique opportunity to hang out with some of them, ask them some questions. I'm going to call out Alex Ellis, who also has an extremely interesting serverless project, OpenFaz. He also has stickers. Alex, you have a talk this week as well, is that?
Yeah, that's right. So I'm going to be speaking on Thursday at 2 p.m. and limited capacity, so you need to sign up today. Make sure you get in. And actually, seriously, you can go to www.openfaz.com, and there's a short video from DockerCon at the Moby Summit. They give you a really good high-level overview. You can find out how it applies to Kubernetes and how it's grown on Thursday. Yeah, thank you.
All right, that's a wrap. I had fun. You guys did too.
Oh, today?
Oh,
Yeah, a couple. I guess people are leaving. I was just gonna say.
And there's someone else who I think might be
great idea.
Well, yeah, we should create an issue anyway, because we haven't got that. Yeah, I think it should be so far I've been oh, okay, right, okay. Yeah, we need the doctor officer
well, we will get back to it. We will actually have some results. Cross our minds. But James, you're right. Oh, yeah. James,
I don't know where they get these stats, you know?